Hello viewers, tutorial 1, question 7, and we have some factorising to do. So this is another expression that has that quadratic look about it. It has an x squared, an x, and a number. But we need to work out what goes inside the two brackets. How are we going to get our 4x squared? Well, is that a 2x times a 2x, or is that an x times a 4x? Could be either one, but only one of those options would work. So we really want to do this by a more systematic way. So let's label our three numbers, our three coefficients, a, b and c. So we have 4 is a, b is -5 and c is 1. Okay, so a times c is 4 times 1 is 4, and b is -5. So we need to look for two numbers that add to -5, but they multiply to 4. What could those two numbers possibly be? Well, let's use the same systematic approach that we used in question 2. So we want two numbers that multiply to 4. One pair could be 1 and 4, and another pair could be the negatives, -1 and -4. Another possible pair could be 2 and 2 and the negatives. Now that is as far as we need to go, because once we've got both numbers in a particular pair, that's all you really need. Okay, so we're going to pick which pair adds up to -5. That is going to be -1 and -4, which is that pair there. Okay, so we're going to use that pair to split up that middle term. That -5x can be written as 4x squared minus 5 is -4 minus 1, so this is -4x minus x plus 1. Now we will factorise in pairs. So out of this first pair, what's our common factor? That would be 4x, and 4x times x gives you your x, and 4x times 1 is 4x. Out of this pair, shall I take out a factor of 1 or -1? I want to keep that sign of the third term of that x, so that's going to be -1 I'm going to take out. So -1 times x gives you minus x, and -1 times -1 gives you +1. So now we can treat this as two terms, each with a common factor of x minus 1. So they both have a factor of x minus 1, and the other bracket is going to be 4x minus 1. So 4x squared minus 5x plus 1 equals 4x minus 1 times x minus 1. And we should check that by expansion, but I'll leave that for you. Part B, we have another question to factorise. We have 6x squared plus 7x minus 10. So we have an A, we have a B, and we have a C. Okay, so A times C is going to be 6 times -10, and B, which is -60, and B is 7. So we're looking for pairs of numbers that multiply to -60, but add to 7, +7. So does 1 go into 60? It does, so this is going to be 1 and -60 is one possible combination, or we could have -1 and 60. Does 2 go into 60? It does. 2 times 30, and the negative could be on the 2, so another pair would be -2 and 30. Does 3 go into 60? This is going to be 3 and -20, and we have -3 and 20. Does 4 go into 60? 4 and minus 15 and minus 4 and 15. So this is going to be a fairly long list. Does 5 go into 60? This is going to be 5 and minus 12, minus 5 and 12. What about 6? Yep, so we get 6 and minus 10, or minus 6 and 10. And what about 7? Does 7 go into 60? Finally a no. Does 8 go into 60? No. What about 9? And 10 we have already. We've got 6 and 10. So that's as far as we need to go. Now we need to work out which pair of numbers, when we add them together, gives us positive 7. And it is minus 5 and 12. So it's that pair there. Okay, so it's going to be, we're going to use that pair to split up that middle term. We're going to write 6x squared plus 7x is plus 12x minus 5x, and then we have a minus 10, and pairwise factorise. So what's the common factor there? That's going to be 6 times x, and the bracket is going to be 6x times x gives us 6x squared, and 6x times 2 is 12x. Now out of this pair, third sign there is a negative, so I want to keep that negative. So we've got a factor of 5. Now 5 times what gives us minus 5x, that's x, and minus 5 times positive 2 gives us minus 10. So again we've got the two brackets there being the same, which we need to have. If not, something's gone awry and you've probably made a mistake. Okay, so we're going to have x plus 2 is one of the brackets. The other one is going to be 6x minus 5. So if we expand that out, we get 6x squared plus 12x minus 5x minus 10, which is 6x squared plus 7x minus 10. Okay, question C. So we need to multiply that through by q to make it a quadratic equation. We don't want any fractions, but we need to remember to multiply everything through by q. So this is going to be 6q. We need to remember to multiply that 6 by q as well, which is a step that is often forgotten. Minus 5q over q. Q's cancel, which gives us just 5. That's exactly why we're doing the multiplication by q. We want to get rid of that denominator. Equals, on the right we will have minus 11q times q, which is minus 11q squared. Now this is actually going to be a quadratic equation. It's different from the two questions that we just factorised because we see the appearance of an equal sign. So we'll move that minus 11q squared to the other side. If we're solving a quadratic equation, we want everything on one side of the equation and an equals 0 on the other. So we've got 11q squared plus 6q minus 5 equals 0. Okay, so now we'll factorise that left-hand side. So we're looking for numbers that, first of all, label it A, B, C. Now A times C is 11 times minus 5, gives us minus 55, and we have B is 6. So we're looking for numbers that multiply to minus 55, but they add to 6. So we'll do our systematic thing again. So does 1 go into 55? So that's going to be 1 and negative 55, and negative 1 and 55. Does 2 go into 55? No. What about 3? Again, that's a no, and the same for 4. But 5 goes into 55. It's going to be 5 times minus 11, or minus 5 times 11. And 6, 7, 8, 9, and 10, none of those go into 55. The next one that does go into 55 is 11, but we already have that. So that's as far as we need to go. We're looking for the pair that adds up to positive 6, which is going to be minus 5 and 11. So we'll write that 6q as 11q minus 5q. So therefore we get 11q squared plus 11q minus 5q minus 5 equals 0. And we'll pairwise factorise as before. So 11q squared and 11q, the biggest common factor we can take out there is an 11 and a q. So 11q, and what goes inside that bracket, that's going to be 11q times q gives us 11q squared, and 11q plus 1 gives us 11q. Out of this pair, let's keep that third sign, which is going to be a minus, and we have a common factor of 5. So minus 5 times what gives us minus 5q, that's q, minus 5 times positive 1 gives us your minus 5 equals 0. Okay, so now we have a q plus 1 in common, and we have an 11q minus 5 equals 0. Okay, so we've factorised our left hand side. Now we're ready to solve it, which means that we want to find the values of q that make it 0. So when we solve a quadratic equation by factorising, we're taking advantage of the fact that if two numbers multiply to 0, that means one of them, at least one of them, must be 0. If you've got two numbers that are not 0, they will not multiply to 0. So to make the whole equation 0, either this first bracket equals 0 or the second bracket equals 0. So either 11q minus 5 equals 0 or q plus 1 equals 0. So when we solve a quadratic equation by factorising, we're really breaking it up into two separate non-quadratic equations, and we can solve each of them separately. So this would be the easiest one to solve. All we need to do to get q on its own is to move the plus 1. So we get q is negative 1 as a solution. And let's check that one. So if q is negative 1, then we get a left-hand side back in the original question of 6 minus 5 over negative 1. Well, that's going to be 6 plus 5, which is 11. And the right-hand side is, if q is negative 1, we get minus 11 times minus 1 is positive 11. So both sides are 11 if q equals negative 1. So it is indeed a solution. Now we turn our attention to this other equation, 11q minus 5 equals 0, and we want to solve that equation. So therefore we move the 5 to the other side. 11q equals 5, and therefore divide by 11, we get 5 over 11 is our other solution. And I will leave that as an exercise for the viewer to check. Okay, thanks for watching. Over and out.